Hi everyone. So we are now going to move into the second half of our functions unit. Today we are going to add, subtract, and also later multiply, divide in this one lesson, even though it just says add and subtract. This is nothing new. All that you're really getting used to is new notation. So the way that we write this when we have function notation is slightly different. All right, so I have f of x is 3x plus 7, g of x is negative 4x plus 11. So you'll notice that the way these are written really commonly, see on the left, f plus g in parentheses of x. That's just a really fancy way of saying f of x plus g of x. We're just adding the two functions. Similarly, below, minus, and you always write the two functions together in that notation, and then you have your x. So f of x minus g of x. So let's pause the video, go through and do the problems. So we're just going to add the two functions. So I have 3x plus 7 plus negative 4 plus 4x plus 11 is negative x plus 18. Done. And then for this bottom one, 3x plus 7 minus negative 4x plus 11, which gives me 7x minus 4. So it's just really understanding when you see this, what does that mean? It just means I'm subtracting my two functions. F has to go first, G has to go second. So pause the video and do these two on your own. So F plus G, I'm just going to combine like terms. So I get 12x to the fifth, and then plus 2x cubed, plus 6x squared, plus 6. So just combining. So nothing combines with that. Nothing combines with that. And our 2 3's go together. And that's it. Now with the subtraction, I usually will actually write these out. So 12x to the fifth minus 5x cubed plus 3 minus 7x cubed plus 6x squared plus 3. So make sure you distribute the negative. So we still get 12x to the fifth, but we get the negative 5, and negative 7 gives me negative 12x cubed minus 6x squared, and then the 3's cancel out. So that is our answer for the subtraction. Okay, so now for multiplication and division. So multiplication, we use a dot, right? We don't usually use x, f times g of x. Again, we put the two functions and then the x is on the outside. All that means is I'm going to take my f of x and my g of x and I'm going to multiply. With division, you can write it like this with the division symbol or f over g. It is the same thing. So let's write out what we get. So 3x plus 7 times negative 4x plus 11. Let's see what we get. Negative 12x squared. Let's see, I get 33x and negative 28x. So that's 5x plus 77. Done. Now here's the nice thing. The division ones are actually the easy ones. So I'm just going to write this as 3x plus 7 divided by, parentheses, negative 4x plus 11. We can't really do anything there. I mean, we could do long division, but there's no real point. Same here, 3x plus 7 over negative 4x plus 11. Now, the one thing you do want to think about is the domain. The domain of f and g in this one, all real numbers, all real numbers. However, when we turn it into a division, remember, what can you not have in the bottom? So it'll be all real numbers except x equals 11 over 4. So that is something you want to think about. The domain changes when you start doing these operations, specifically division. All right, pause the video, do this one on your own. So for A, we're going to multiply. So I'm going to do that up here. 5x squared minus x plus 4, 6x squared plus 3. Let's see, 30x to the 4th plus 15x squared minus 6x cubed minus 3x, 24x squared, and 12. So I did the 5x first, then I did the x, and then I did the 4 last for both of them. All right, combine like terms. I got 30x to the 4th. And then the next is the negative 6x cubed. And then I have 2x squareds. 15 and positive 24 is 39x squared. Minus 3x plus 12. And then division. F is 5x squared minus x plus 4 over 6x squared plus 3 versus, excuse me, 6x squared plus 3 over 5x squared minus x plus 4. So now these are two very different functions. The domain and range is going to be different. Right? My domain for this one is going to be all real numbers because you can never let, the bottom will never equal 0. But this one, that's a factorable problem. We can solve, we can say, oh, this is 5x, x, is that factorable? 20, yeah. Minus 1, 20. No, that doesn't, never mind, I lied, that's not factorable. You'd have to do quadratic formula to figure out where the denominator equals 0, and then you can say, okay, the domain is all real numbers except, and the range is all real numbers except 6 over 5. All right. F times g of 3. So now we're going to plug in. So you have an option. You can multiply out and then plug in 3, or you can plug in 3 independently and then multiply your answers. For these, I think it's easier just to multiply. So I'm going to find f of 3 first, then g of 3, and then multiply. So if I plug in f of 3, that gives me 9 minus 5 is 4. The square root of 4 is 2. 2 times 2 is 4. Times, plug in 3 here, you get negative 6 over 8. So that's negative 3 over 4. So I get negative 3 as my answer. All right, f of 2. If I plug in 2, I get the 2 times the square root of 1, which is 2, over, whoops, plug in 2 on the g, we get negative 7 over 7, negative 1. So we get negative 2. And then the last one, g of 5. Let's see, g of 5, we get negative 4 over 10. So that's negative 2/5. All over, plug in 5 for f. I get 15 minus 5. Well, this one's no fun. 2 root 10. So the 2's end up canceling. And I get negative 1 over 5 root 10. I'm going to rationalize my denominator. Negative root 10 over 50 is the final answer. So notice how different the f and the g, f over g and then g over f are. And that's the lesson. So really it's just practicing with operations and plugging in. It's really no new stuff. It's just getting used to the notation with functions. Have a great day, guys.